Welcome everyone. This is part 0 of 10 of the Crystal Clear Electronics video series. We present chapter 16 titled Accurate Timing Timers in 4 videos. Today's lead presenter for the 4th time is Szabolcs Pájer. I am Ádám Szabó. You may have met me in our previous videos. Today I have brought you a programmable Lego cube from my childhood, which also works on a timer basis. We can record a sequence of movements and it can play them back for us even on repeat. Now I'll show you how it works. Press the red button. This starts the recording and then records the movement. Press the red button again to stop it. And now the robot will replay the recorded movement for us on repeat.
Sziasztok!
Hi, I'm Szabolcs Pájer. I teach mathematics and physics at Bolyai Practice High School, and I hold the electronics study group for my students.
Diákjaimnak.
Chapter 16 was written by László Treszkai, who introduced readers to the world of timing using a binary clock as an example. Let's take a look at this topic in a presentation by Szabolcs Pájer.
In this chapter of the curriculum, you can learn about the basics of timer peripheral programming that will benefit your electrical engineer or software developer career.
Amelyek hasznossá válhatnak akár egy villamosmérnöki, akár egy szoftverfejlesztői karrier során. Egy digitális óra.
We will write the software for a digital clock in 2 ways. First, without using the timer peripheral, and then with it. Let's start in the Stone Age first. We have a processor, and we want to build a digital clock that looks good for the next part of Back to the Future.
Akár a Visszajövőbe című filmben is.
What does the simplest digital clock do?
Ádám órája.
Adam's watch is now showing something, counting down the seconds.
Ahogy látjuk, számlál, a másodpercek számlálását látjuk.
You could say that a clock continuously displays the time in seconds from when it was turned on.
A gyakorlatban
In practice, this means that the value of a counter is increased every second, starting from 0 at midnight and returning to 0,
86.400.
and it overflows after 86,400 seconds, which is a day. The value of this counter is displayed on the watch, usually in the hour, minute, second format.
Másodperc formátumban. Egy bináris
On a binary clock, LEDs indicate the hours, minutes, and seconds as binary digits.
és másodperceket. Az ábrán
In the figure, the LEDs in the bottom row indicate the seconds.
a 32-es, a 8-as,
LEDs 32, 8, and 2 are on, which means 32 plus 8 plus 2 equals 42. It means 42 seconds.
jelöl. Az órák
At the top of the hour row are LEDs 16 and 1, and at the top of the minute row are LEDs 16, 4, 2, and 1.
LED világít. Így
The time displayed on the digital clock is therefore 17 hours, 23 minutes, and 42 seconds.
2 másodperc. Honnan tudja?
How can a digital clock tell the time? Usually, it can't. It simply starts counting from 0 when you turn it on, and the time needs to be set manually.
Is a lehető
In the example code, we will solve this in the simplest possible way.
legességgel pedig az órák érték.
One button to increase the minute counter, and another to increase the hour value. This solution is far from perfect. It's instructive to think about how to make it easy to use, not easy to develop.
A fényforrásként választott
The LEDs, used as a light source, can be connected between the microcontroller pin and ground, or the negative supply voltage, via a resistor connected in series. So, if you want an LED to light up, you need to set the output of the microcontroller to high.
a bemeneteket alap
By default, the inputs are pulled up by the microcontroller's internal pull-up resistor, and the push buttons will pull them down to the ground when pressed.
így a szoftver
Thus, pressing a button can be detected in software by reading a low value on the input.
még azt kell eldönteni, hogy
You have to decide what kind of LED and resistor to choose from. These two questions are related because increasing the value of the resistance causes the current of the LED to decrease, thus decreasing its brightness.
adott típusú LED fényereje
The brightness of an LED increases proportionally with the current flowing through it. In general, we would like a light source to be as bright as possible, but the maximal current of both the LED and the microcontroller outputs is limited.
Az előbbi
The former can be read from the LED datasheet, but most of the LEDs will endure up to 20 milliamperes.
a kimenetek áramkorlát
The current limit of the outputs is in the microcontroller's datasheet in section 27.2 under the DC characteristics table.
az A-port kimenetei
The outputs of port A can be loaded with a total of 100 milliamperes, and the outputs of ports B and C altogether can be loaded with a total of 100 milliamperes in case of the PDIP package.
a B-portra
Port B has 5 LEDs, and port C has 1 LED. If the same current flows through these 6 LEDs, it means a maximum of 16 milliamperes per output. We will get the same numbers for port A as well.
az ellenállás méretezéséhez
We need the current and the voltage in order to determine the value of the resistance.
a rajta eső feszültség
The voltage on it depends on the voltage drop on the LED, which depends on the color of the LED and the current flowing through it.
az általunk használt
On the red and green LEDs we are using, there is a voltage drop of about 2 volts at a current of 16 milliamperes,
feszültség esik, úgyhogy, ha ezt kivonjuk a
so if our supply voltage is 5 volts, then 3 volts can be measured on the resistor connected in series.
3 volt mérhető. Az ellenállás
The resistance value can finally be calculated using Ohm's law. If we divide 3 volts by 16 milliamperes, we get about 190 ohms.
minél nagyobb az ellenállás
The higher the resistance value, the less current flows through the LED, so the value of our resistance should be at least this high.
a kapcsolásban. Ádám,
Adam, I hope we did it this way, so there's no resistance on the test panel due to it being lower than that.
Természetesen
Of course, we use 330 ohms of the resistors available.
használtunk.
Very good.
ez volt
It was the first video in the 16th chapter of the Crystal Clear Electronics videos.
a következő részben
In the next part, we will create our first program for our digital clock.
programunkat.
Bye!
Bye!